Hello, my name is Roxanne Truand. I'm the coordinator of the Michigan State University Science Festival. Welcome to the Citizen Science Panel Talk, Anyone Can Be a Scientist. We're excited to share with you from a panel I've put together all about how you can get involved in community science, or citizen science as a lot of people know it by its name. I want to introduce our panel members to you today. First, we have Kristy Taylor. She's the Education and Outreach Coordinator for the Michigan State Bird Observatory and serves as President for Capital Area Audubon. She is constantly curious and loves to learn about scientific research, especially in nature-related fields. She has a lifelong love of birds, but started birding in earnest about 8 years ago. Kristy loves to learn about the ecosystem and enjoys teaching others how to be a part of community science projects like eBird, Merlin Bird ID, Project Nestwatch, Project Feederwatch, iNaturalist, Zooniverse, community monitoring projects, bird banding reporting, and more. Next, I'm joined by Dan Auer. He's the program director for Waldemar Nature Association in Lansing. Dan is a graduate of Central Michigan University, where he got his BS in environmental science and conservation biology. During his undergrad, he was part of a lab studying freshwater ecosystems, focusing on our native freshwater mussels. Before working at Waldemar, Dan worked for the Battle Creek Public Schools at their outdoor education residential school camp program and the Kalamazoo Nature Center, working on invasive species and habitat restoration. Dan's passion for plants has grown with his use of citizen science apps like iNaturalist, which he will focus on during the panel discussion. Next, we have Emma Campbell. She's the Land Stewardship Coordinator for the Meridian Township, where she guides land management decisions and organizes volunteer stewardship across 1,700 acres. As a stewardship coordinator, Emma's biggest passion is community engagement and outreach to improve our natural areas. And next, we're joined by Steve Marquie. Steve has worked for biosystems and ag engineering at MSU as the departmental instrumentation specialist since 1996. In 2002, while continuing his assignment with BAE, he began a nearly 20-year assignment with the MSU Agricultural Weather Station Network. He teaches various instrumentation labs and offers a project management instruction to the department. His 25-year career at MSU has provided opportunity to contribute to many projects, including a solar-powered irrigation system, electronic controllers for ag mechanization, and expanding the EnviroWeather Weather Nation network. He collaborates with many departments in College of Ag and Natural Resources and is a project manager for research efforts in Peru, South America. Outside the workplace, Steve enjoys many hobbies: amateur radio, guitars, motorcycles, cars, and travel. And last but not least, Joshua Hamilton graduated from Michigan State University with a BA in Media and Information from the College of Communication Arts and Sciences. After working for Ingham County Central Dispatch for a couple of years, Joshua was hired as the Director of Youth Ministry and Confirmation at St. Thomas Aquinas Catholic Church in East Lansing. He now serves as the Director of Adult Faith Formation at St. Thomas. As a citizen scientist, Joshua has been on the citizen science team for NASA's Disk Detective project for many years. He has classified over 75,000 stellar disk images, has co-authored 2 NASA published papers, and has also discovered and named 2 variable stars, HJRA-V1 and HJRA-V2. So please join me in welcoming this panel. We're going to start out the day by asking our panelists a little bit about their institution and program. And we'll start off first with Kristy Taylor from the Michigan State Bird Observatory. Thank you.
A lot of the community scientists are the same as you. We have passions, we're outside, we get curious, and then we find out ways that we can help contribute and help preserve the things that we love. So one of the things I love is birds. I'm wearing a bird shirt. I have bird cups. Every birthday I get something bird related, and I love that. But birds really are important. They can tell us a lot about the environment. They need clean air, clean water, plenty of food to survive. They need a lot of the same things that we do. They can tell us about the health of our ecosystems, and they can be found in all different habitats, anywhere from Antarctica, they can be found in the desert, and most importantly, they can be found right in your backyard. At the Michigan State Bird Observatory, we have scientists that study birds. They do this in a little different way. So we set up mist nets. These large nets are in migratory stopover points. So these are in areas where birds are migrating at night, they're coming down in the morning, and they're foraging for food, whether that be berries or insects. And we set up these nets because we need to learn about these birds by looking at them a little closer. So these birds will get a little bit tangled in these nets, and our trained scientists will go out and safely collect them and bring them back to our bander. Our bird bander has to know all of the different species of birds that visit Michigan during migration. And it might not seem like a lot to you, but over 450 different species of birds visit Michigan. Here our bander is looking really close at a bird, and we can look at the muscle and the fat so we can tell the health of that bird. Looking through binoculars, you can tell a lot about birds. You could maybe tell the quantity that's moving through your area, maybe the sex, if it's a male or a female. But it's hard to tell if that, is a juvenile bird, a baby bird, or an adult. And we can tell this by looking up close. So once we give this bird a unique band, and you can see the metal band on that bird, then we release that bird safely back into the environment. Now that metal band is where community scientists come in. So you can look at a bird, maybe at your bird feeder even, and this is really cool. Just this week, someone on Facebook posted this image. Now, I don't know if you can see it. You have to look pretty close. So this is a really, really awesome find. But you can see this bird's leg has a little silver band. And this was in Berry County, Michigan. So it's in Hastings area, just a little south of Lansing. So this is a song sparrow. This is exciting to me because if she can figure out what those numbers are, she can help us learn about this bird. This bird was banded somewhere, whether it was here in the Lansing area by the Michigan State Bird Observatory or somewhere else. And by community scientists paying attention to bird bands, maybe you find a roadkill bird. Take a look at the legs. It might be a little bit gross, but you can look and see if there's a band on there because that helps us tell, where did this bird go? What ended its life, or where is it moving? It could tell us where it goes during the winter or even where it's going to breed. So your observations really, really help these scientists. And today you're going to learn a lot about this, and I'll share some more about the specific programs that I'm really engaged in. But I just want to encourage you, everyone is a scientist. People of all ages can participate in community science. This little guy here in the middle, that's my son. This was a number of years ago. He's a 5'5" teenager now. But this is one of the bird walks that we went on, and we recorded all the different birds that we saw during this walk. So I would encourage you, even if you're just starting out or you don't know a lot about birds, you can contribute as well.
Thank you, Kristy. And now, Dan, we'll have you say something.
Hey, hi, everybody. Let me share my screen real quick. And slideshow. So thank you, everybody. My name is Dan Auer, and I'm the program director at Woldemar Nature Center here in Lansing. Woldemar is for the naturally curious, so we fit really well into this area of citizen science. We believe that outdoor education and appreciation, it should be for all, and can have a way for everyone to get engaged in their natural area. Woldemar is a private nonprofit. We are a member-led organization for community and science nature education. So our mission at Woldemar is to educate people about the natural environment. So everything we do relates to that mission. That's our foundation and the light at the end of the tunnel. So we work every single day to reach our community. One of the ways that we reach our community is by our 180 acres that we have right off of Old Lansing Road. So if you've been out there before, it's a really amazing, diverse ecosystem. We have prairies to old growth forests to wetlands, ponds, vernal pools, and 1.25 miles along the Grand River. So each of these different habitat types provides a lot of really great opportunities to see different Michigan ecosystems. And then kind of get an idea of maybe what the lower part of Michigan looked like before there was lots of farming. And then we also have a great history of farming here. So this property was part of Gladys Olds Anderson's dairy farm before it became a nature center over 50 years ago. And so we have some of the leftover buildings. We have the barn and an equipment building from this time that we use for our educational programming. And then you get to see what the land looks like post-farming. So that agriculture is an important part of our economy here in Michigan, and seeing how it affects the environment, and then how the environment recoups after an area is left fallow. So we use iNaturalist and other citizen science apps a lot to collect data to help us understand what's going on here on our property, help us with our educational programs, and then be a resource to our scientific community that might be looking for research sites or things that they're looking to study and need a place to do that. One of the things I'm really proud of is Woldemar is Eaton County's #1 bird site on eBird. So if you love birds, come check us out. Right now, I just opened up iNaturalist to look at it, and I'll explain a little bit more about how to use the site. But we have a total of 691 observations so far at Woldemar Nature Center, and that's a total of 337 individual species just in the time that this iNaturalist app has been going, which has only been a few years. So it's a really amazing opportunity. You might not realize just how many species use a place like Woldemar or are native to here in Michigan. And so get outside, get excited. I'm really excited to share your opportunities at Woldemar and the use of iNaturalist. So let me stop sharing. Thank you.
Thank you, Dan. I'm excited to come out to Woldemar Nature Center. Now we'll next go to Emma Campbell from the Meridian Township.
Hello, everyone. Thank you for having me today. Really excited to be here and share what I'm doing over at Meridian Township. And I used to work at Woldemar, and it is indeed a very special place. So I am the Land Stewardship Coordinator for Meridian Township Parks and Recreation Department, and we have 26 parks and 23 land preserves. And so I lead the land management decisions made on each of those properties, which of course varies since parks are very different than preserves and they have a whole different set of rules. But you know, within land management, there's so many factors that we have to think about. One of them being invasive species management. So invasive species are a huge threat to our native ecosystems, and they're continually taking over our native ecosystems every day. And I'll kind of talk a little bit more about what invasive species are. So that management is a really big component of my job. Now, like Roxanne said in my bio, there's 1,700 acres and there's one of me. So how in the world am I gonna, wrap my head around all that work and what is gonna go into that? And that's where all of you come in as citizen scientists and as volunteers of stewardship. You are really the huge cog in the wheel that is going to make all of this happen. Because I can have so many visions of what I want to do on the land, but I cannot do it by myself. So that's where our Meridian Conservation Corps program comes in. So the Meridian Conservation Corps was, I just launched it last September, and it's been incredible to see how many people are taking part in this program already. We have 4 programs currently out and running, and we're releasing 4 more this year. One, which is currently in the process, is the Vernal Pool Patrol. So the Meridian Conservation Corps is just a way to get everyone who has any interest, any knowledge, any passion. It doesn't matter what level you are. We all are capable of being stewards of the land. We all live on land, even if it's a very small plot of land. So we all have that capability. And so this Corps is just a way to get everyone together and coordinate, connect people. It's not always about reinventing the wheel. There's a lot of amazing and incredible programs and organizations out there already. So it's also about connecting my volunteers to those programs. So one of our biggest programs is the Invasive Species Strike Team. So that's what I'm going to be talking about today, the program that I'll kind of discuss a little more when we get to that. And, you know, I have all my contact information. If you live in Meridian Township and you're interested, I'd be more than happy to get you set up. But again, there's just so much for land managers to do. And it's really the community that's going to help us get all that done. So I'm just the coordinator of that. And really everyone else is the really important part. So I will talk more about my program when that time comes, but.
Thank you, Emma. Next, we'll be joined by Steve Markey from the Agriculture and Engineering to talk about his area of expertise on the weather maps.
Well, thank you very much, Roxanne. So good morning, everyone. My name is Steve Marquis with the MSU Biosystem and Ag Engineering Department. I'm also the Field Operations Manager for the EnviroWeather program, which you might have heard of. It's a weather station network that has been around the state of Michigan for a little over 20 years. And the scene behind me is that of an image of one of our weather stations located near Onekama, Michigan, just south of Frankfurt. And it's in a beautiful setting of apple trees. So at a nice apple orchard there. So let me share a little bit with you, and we will jump right into this. So I just want to talk a little bit about personal weather stations. So yes, indeed, the EnviroWeather program covers the entire state of Michigan. Each one of the little dots, if you go to the website that you see before you, is at one of these weather stations, and it provides great near real-time information that helps both growers and people in the ag and natural resources field make best management practice decisions on their crops, their orchards, and their outdoor activities. But these weather stations aren't inexpensive. As you see, this is the station in Onekama. These are pretty expensive, very costly pieces of instrumentation. They're referred to as research grade instruments and run in the upwards of $7,000 to $8,000 per site. A lot of money for the average person to invest in. What I want to talk to you about today is share ideas on how you can become a contributor to monitoring the weather. There are many aspects that you can become engaged in. One is probably the least expensive and one of the most appreciative organizations that has a community monitoring system. It is called COCORAS, short for Community Collaborative Rain, Hail, and Snow Network. It's out of Colorado State University. And for a small fee, under $25, you can become part of this, and they'll supply you with a very simple but highly accurate precipitation gauge. And on a daily basis, you report your daily rainfall. You can also report hail and snow. If you want to ramp up your efforts just a little bit, and here's an example of COCORAS, and all that data comes into a central database and is shared back out with the public. If you want to ramp up your efforts just a little bit, you can become involved in personal weather station activity. And what it really is, that we'll talk a little bit more about. But personal weather stations are hobby grade, not quite as expensive, somewhere between $400 and $1,500 in cost. and provides reasonable information that likewise is shared throughout the world. Those activities collect the data and feed it into a central database that is maintained by Utah State University. And we'll perhaps visit their website a little later today, and I can share with you what is how that information is used and how you can become part of the Personal Weather Station network.
Thank you, Steve. We'll be taking weather a little more in depth in a little bit. And finally, we're joined by Joshua Hamilton, who's going to talk to us. We're getting out of the natural world. Well, I guess it's still the natural world, but we're going to go out in space, and he's going to talk to us a little bit about the NASA Citizen Science Project.
Thank you, Roxanne. Like Roxanne said, my name's Josh. I am a citizen scientist or an amateur scientist. As you know, some of the other projects discussed, I'm sort of often on the other end, entering data in, and I use Zooniverse, and I actually started working on Zooniverse 6-7 years ago. If you've never been to Zooniverse, I highly recommend you check their site out. You can do a plethora of different citizen science research. What Zooniverse basically addresses, there's this problem in science. The old problem was we didn't have enough equipment and people to do the monitoring, right? Because you had to have somebody sit at a telescope that was very expensive for the space work that I do and write down what they saw. But the problem is actually flipped 180 because we have these incredible smart robotic cameras with mirrors that are anywhere from 8 to 30 meters wide. So some of these mirrors, if you lay them down, would cover almost an entire football field. So they can take a picture, you know, that covers a good chunk of the sky. And so what my project, Just Detective, addresses is something called the WISE survey. And the WISE survey was basically using a different kind of light than visual light, infrared light. So again, looking for heat instead of looking for color. Because in the night sky, what you'll notice is there's not a lot of color, right? If you look at things, the only things with color are planets. Everything else from the naked eye appears black and white. So we use infrared imagery in the WISE survey, and the WISE survey took millions of images. And what the WISE survey in particular was looking for was disks. And if you kind of look behind me in my little image here, this is actually a rendering of what a disk might look like if we were up close and in color. Now, don't let the size that sort of fits behind me deceive you, right? If you imagine the little dot in the middle, that would be like our sun. And then you can see these 3 little dots. And these would be, say, the 3 inner planets, you know, Mercury, Venus, and the Earth, starting to form. And so what basically happens in the solar system is that there was a cloud of dust, and there's dust all over the sky. Again, another reason we need infrared is so you can actually see through the dust, because otherwise you'd only be able to look out so far that you'd be blocked by basically a curtain of dust in the universe. So Big Bang blows up. This is way oversimplification, but there's dust, and then dust in zero gravity does this really funny thing. If you go to the beach, 2 particles of sand don't move towards each other typically, right? They don't attract each other. If they do, you need to seek help because you're seeing things, right? But in space, this really weird thing happens. If there's 2 pieces of sand and they're floating in space, they actually have a gravitational pull on each other. You wouldn't think of a piece of sand as having gravity, but it does. And if there's no other gravity present, they come together. So these dust clouds collapse and collapse and collapse. And basically there's so much heat and pressure at the center that a star literally explodes. So you can see in the middle of this image, you've got the star there with some space around it, right? The cloud has collapsed and blown up. And that star now provides heat and gravity and even centripetal force, right? So the disk spins. And then planets eventually start forming with that same kind of process. Dust wants to attract itself. So if there's 2 grains of sand, they have more gravity than 1. So 2 becomes 4, and pretty soon you have planets, planetesimals, you know, meteors, comets, all these things. The problem is we didn't, you know, there was no like selfie video as the solar system was being developed. And so even though we think we understand how our solar system was formed or how all other systems, stellar systems were formed, we really don't understand exactly how it happened. For instance, Saturn and Jupiter in our solar system appear possibly to not be in the right order. We're not really sure why we have some guesses as to why they might have flipped. In some planet systems, you'll see a Jupiter-sized planet that's like as close as Mercury. Well, that's kind of confusing because Jupiter-type planets are ice and gas and they're cold, but here it is right next to a star. So there's a lot of confusing things that we don't understand. So our project seeks to take a wide array of this WISE data and learn basically about disk formation. The benefit of the universe is there's so many different replications of the same thing that we can sort of take, okay, this one's in the early stages, this one's in the next stage, this one, and we can almost build a timeline of how disks develop. What the main issue is you've got 2 million images, and even for us to look at the images, you struggle to filter out, and algorithms and computers actually have a really hard time doing this kind of filtration. And I'm not going to share the screen now because I'll show you how to actually work the project. But we use citizen scientists, we use you all on Zooniverse, almost like you're playing a game or like a video game, but you are trained to look at these images and pick out things like multiple objects inside the circle. You'll be trained to pick up things like, does the image extend beyond the circle? All of these things, what it does is it tells us these images, not that there's anything wrong with the star, but that we aren't going to be able to get useful scientific data out of it. And then my team, so I joined the citizen science team after a couple of years of training, and our team, so let's say there's 1 million objects. You all listening, the citizen scientists, you maybe filter it down to, 10,000 really good images, and you say they're clean. These are all clean images. We are trained to take that and take it down to 30 or 40, and then we bring that before our chief scientists, our team of scientists, including us, and we start to theorize and we start to learn about, okay, how are these disks useful? And we actually, one of the papers that I was able to co-write, the last thing I'll share here, which was really interesting, we discovered a totally new type of disk, a disk that we've never seen before and we can't really explain. It's very funny, it's called a Peter Pan disk. And the reason we call it a Peter Pan disk is because it won't grow up. The disk appears to be young, the star appears to be old, and that really confuses us because we've never seen it in that order before. Typically, we figured it was fairly linear, that things kind of evolve over age, and yet you find a really old star with a really young disk. But thanks to the hundreds and hundreds of citizen scientists, and again, these citizen scientists classify thousands of images. I've looked at over 75,000 images myself and classified them, but there's millions of images to look at. But thanks to those scientists, from 1 million to 10,000 to 30 to 1, a brand new class of disks is discovered. And so it's really useful science, but it's also great because if you're an insomniac and it's 10:30 at night, you can just sit up in your bed and do this kind of science research. Now, I certainly like getting out into nature, but when it's raining or it's freezing cold, this is a great project to just sit around and do, even while you're watching a TV show. And again, I'll share more about how to actually use the program later. I didn't want to share the image yet, but I'll show you later how to actually do it.
Thank you, Josh. That was very exciting. We all, I think for me, I grew up with NASA, and anything we could do to help NASA would be awesome. All right, so next we're going to talk about the areas of citizen science and what you need to get started for those different citizen science projects. You don't, in some cases, need a lot of things, just your eyes and a phone to take a picture. So we'll start again with Christy Taylor from the Michigan Bird Observatory.
Awesome. Well, welcome back. I'm going to share again. So I have a couple of different programs that we can look at together. So there are a lot of different ways that you can get involved with helping birds and studying birds. Project Nestwatch, Project Feederwatch, Merlin Bird ID, the Audubon App, eBird, iNaturalist, and then there are also walks that you can be a part of, like the Christmas bird count, the backyard bird count. You can locate a bird ban and go to reportaban.gov, and you can volunteer. So I'll share a few of those with you today. I'm going to go through these really quick because there are great resources online. If one of these kind of appeals to you a little bit and you're like, oh, I really want to find out more about Feederwatch, look up Feederwatch, Google Feederwatch, and you're going to find videos that will help you do it. Each of these websites has great training programs so that you can learn how to do it correctly. You might find out, you know what, that program's not for me. There's probably something else out there that'll fit well with your interests. So birds need our help. Since 1970, 2.9 billion birds, that's almost 1 in 4 birds, are gone. So the reason we know this is because researchers have looked at population data over time. So some of these programs are ways that the community, even your sightings in your own backyard, can help contribute to that population data. You can look at home-based projects. These are one that you can do from home. Like, you know, the Insomniac at 10:30. These are, some of these are ones you can work at. And Zooniverse even actually has some bird programs too. But report a band if you have a window collision at your home and you find a bird that has a band. Reporting that band if you're a hunter and one of your one of your harvests that year has a band. It's important to report that. But Project Nestwatch and Project Feederwatch can be done right in your own backyard. We have a robin, we call her Gutter Robin. She nests on our house, on our gutter, every year. She normally has 2 broods, which means she makes a nest. Those hatch and fly off, and then she has another batch of eggs. So we get to see, normally her first batch will have 3 eggs and her second batch will have 4. We've learned this because this is the 3rd year we've watched her. So if you want to engage your children in how to see that life cycle kind of unfold, that's a really great thing for them to learn. And it also teaches them how to observe nature in a safe manner. So Project Nestwatch is a great one to do right from home. Project Feederwatch takes place during the winter. So this one is one where twice a week you look out your back window at your bird feeder, write down the birds that are visiting, and it helps scientists learn about the population changes over time. Some birds are pressured much more with climate change than others. So we want to learn what birds are still utilizing feeders, how far these birds are moving during migration, and then again, when they come back. So that one can be done right from your own backyard. And this is the Project Nestwatch. So it's really, really cool to see these eggs go from those kind of creepy little hatchlings there all the way to these little fluffy robins. The next thing I'd recommend is Merlin Bird ID. And Merlin Bird ID isn't a typical community science program, but your sightings will help contribute to that eBird data. Merlin Bird ID is the #1 program I recommend for beginning birders or just generally curious people. Merlin Bird ID will walk you right through how to identify a bird. It is a free app you can download on your phone, and it also includes a bird guide and bird sounds. But it'll ask you, where did you see this bird? And you can see some of the suggestions it gave me. I kind of wish I was in Florida right now, but it's a beautiful sunny day out today. So when did you see the bird? I have April 1st on here. When we see a bird is really important for science. Michigan has a lot of migratory species. So there are some birds that are not going to stay here in the winter. They're not going to stay here in the summer. They're just going to stop by and eat on their way to somewhere else. So it's really important to know the date there. The next thing it'll ask is the size of the bird, and it will use birds that you already know. So was it about the size of a sparrow, or the size of a robin, a crow, or even a goose, and a couple in between there. So once we know when it was, how big it was, it'll ask the main colors. And now some of you might be onto the bird that I'm kind of guessing here. It's about robin size, and it's gray and white and orange. And it will give you another thing, and this is what birders really look for. And this is the behavior. And it will ask you, was the bird eating at a feeder? Was it swimming or wading? The bird I saw was on the ground because oh, there we go, there's our robin. So if you did guess it, most of you should recognize this bird. But the behavior of the bird is going to tell us, it'll help us narrow it down from other species. You're probably not going to see a robin soaring, right? So Merlin Bird ID uses that data to help other people identify their birds, and then it also contributes that data to eBird. So the next thing I'll talk about are some field-based projects. So if you want to get out in nature, you want to go somewhere other than your backyard. And this is my daughter, and we were on a hike, and she's wearing our hiking backpack. This, I believe, is at the Capital City Bird Sanctuary, which is just north of Lansing. But there are a number of different ways you can get involved in monitoring birds in the field. The Christmas bird count happens every year in between, I believe it's December 15th and January 5th, something right around there. But you can join a count in your area. There's a 15-mile count circle, and it's a really, really great way to meet birders in your area. The backyard bird count can be done right in your neighborhood. There's the biggest biggest day and Merlin Bird ID. The Audubon app is another free app, and you can also use eBird and iNaturalist to monitor birds. Christmas bird count can be found at audubon.org. They have a lot of free information there about that count. The Audubon app is another free app that will use your sightings to help other people and to record that population data. The Audubon app also has a very cool feature so that you can find other places to explore in your area. Here, if I clicked on, I think I clicked on Moore's Park, but I click on Moore's Park, which was near me, and it showed all the birds that were in my area. Now, eBird, if you get used to birding a little bit and recording your sightings, eBird is a really valuable resource for scientists. And now you're recording the species of bird that you saw, the quantity that you saw, and the amount of time you're spending in nature. Now, we have a list for our backyard. That's just the species we've seen in our little neighborhood. And then whenever I'm on a walk, I will keep an eBird checklist. It helps to learn when birds are moving through. It can also be used for rare bird sightings. So if you see something that's not normally in your area, it can alert scientists to their presence. There's a great resource if you're interested in learning more about eBird. The academy.allaboutbirds.org has a great video that you can watch to get started. eBird also has hotspots, and earlier I think Daniel said that Woldemar is one of the top hotspots in his area in Eaton County, and this is a great place if you're looking where to take your kids to see some birds, where to go with your family, or if you're by yourself, like I want to go on a hike and I want to see a diversity of species. Well, here on this hotspot map, you can see the darker red the color, the more species have been reported at that area. And this is an area in Michigan, Tawas Point State Park, you can see is a great migratory stopover area. So you can see that species kind of jumps right there. The last thing I'll talk about is volunteering for birding organizations. There are a lot of different specific programs that need your help. Michigan Audubon has chimney swift counts. They also monitor purple martins. They have nest box surveys at many of their sanctuaries around Michigan. And then they also have a window collision survey project. Any of those you can learn about more on their website. The Audubon Society, Audubon Great Lakes, has Climate Watch and a secretive marsh bird survey. Michigan Audubon has a Young Birders Club, and then Capital Area Audubon and many local chapters have ways that you can get involved in monitoring birds and learning more about birds.
Thank you, Kristy. As a fellow bird lover, I've taken part in both the Christmas Bird Watch and the Feeder Watch from the comfort of my home, which is kind of nice. So I do appreciate that. And I will say to the audience out there, if you have questions, go ahead and type them in the Q&A and we will answer those at the end of the talk. So now we'll change gears from birds and go over to Dan, who's going to talk about iNaturalist. And I just want to give a shout out that the MSU Science Festival is having a BioBlitz based on the iNaturalist app. So you can go to our website to learn more about that. Thank you, Dan.
Yeah, absolutely. I'm excited about that. And a BioBlitz is a fantastic way to try to identify as many things as you can and throughout the entire month. And as Woldemar is one of these sites, if you use the iNaturalist app at Woldemar, you will already be able to contribute without having to do anything. But if you'd like, you can go into the projects section of the app and sign up for each program. But because there's a geotag using your location through your phone, you don't have to worry about it. It'll automatically add it in there. So for iNaturalist, so this is a great partnership between the California Academy of Science and National Geographic. and they have put this app together, which has really been a revolutionary change in our ability to identify things out there. If you have ever been curious about, what is that? This is a great app for you. So all you need to do is have a cell phone, and then and be curious. So you can download this app, and you can go out there and record the observations of things that you find. So what did you find? Maybe I saw a butterfly, or I see a plant or a tree. I'm not sure what it is. Then you'll also, as you're taking a picture of it, it will record the location and the date that you saw it, and it'll add this into the app and help you identify it through a set of pictures. So here's really quick, once you identify, or you're ready to get started with iNaturalist, first, you're going to download the app either from the Apple Play Store or Google, or whatever phone you have. If you are not using a cell phone, you can also do this from a desktop computer. You just need a way to upload photos that you take in the field to your phone, to your computer. First, you're going to click Observe. You're going to tap Observe, and you're going to add in your pictures. Okay, so it'll bring up your camera, and you can take a picture of it. Take as close of a picture as you can, and gather as much detail about the plant or animal as you can. But if it's not the greatest picture, you can take multiple pictures as well. So we get in here, you'll have the picture that you had. You can also add more pictures if you'd like. And then next thing, you're going to say, what did I see? And you'll click on that, and it'll give you a list of possibilities of what you saw. And 9 out of 10 times, what you saw in the algorithm in the app is the first thing on that choice. So you can click on it, and you can figure out more information about it. If you've allowed your app to have access to your location, it will autofill when and where you saw this information. This is really important for scientists as well. Like we're all talking about knowing when we saw it throughout the year. So right now I can go out onto the Woldemar's project and see our property. And we now know that we're starting to see garter snakes and what sort of birds that we're seeing. So it helps us as scientists and as educators to know what we might be able to see out on the property when we're taking our students out for a lesson. And then at the bottom, you're going to save your location. It's going to be uploaded into this community of people who are able to use this data and look at it. As a general observer too, if you're really interested about what's being seen at Wildemar, you can go into the app and click on observations and see what's going on. So if you're curious about, I wonder if I can go out to Wildemar and where are the green frogs? I want to see a green frog today. Or I'm curious about, where might some snakes be? Or I have a research project involving this certain plant. You can use that to help you find these areas where these plants, animals, fungus are located. One of our biggest and most popular events of the year is our fall fungus foray. We partner with MSU's Graduate Women's in Science to help us deliver that program, and we use iNaturalist to help us identify the fungus. And it's just a fun old time. Okay, I have a quick little video here from iNaturalist. It explains how to upload an observation. So let's give this a shot. Hopefully you guys can hear it.
Okay, so you've installed the iNaturalist app. Time to get outside for your first observation. Any living thing, plant, animal, or fungus can be an observation on iNaturalist. Once you find something you'd like to explore, just tap Observe and take a photo. Look at your picture and advance the possibility. To identify it, hit what you see. If you have an internet connection, iNaturalist will suggest a visually similar species and often a common system. You can choose one of those or search for species. On this observation detail screen, you can add more photos of the same organism or webcam. also change the geoprivacy of the observation. Mark whether it's captured or cultivated, or added to the project. Once you're finished, just hit share. Your observation will be uploaded wherever you see and identified. That's it. Keep on exploring and share.
Okay, thank you. Let's end my sharing.
All right, Dan, thank you for that quick tutorial on iNaturalist. I love using that. And I think you can also say you need help identifying it, and then people will come in and offer recommendations. Is that true also?
Absolutely. I try to get on there about once a week and look at the specific location of Woldemar Nature Center and help identify anything that has been found on the property. So, and if I don't know, I can reach out to our great community of observers and identifiers and help us identify that. So there's a great community out there to make sure we get the most accurate observation. Just recently, we got in a little bit of a back and forth about a snake species, which was a brand new snake species to Woldemar. We had never observed it before, so check out the app to see which species it was.
Oh, now I'm curious. I would look at the app to find where the snakes are so I won't see them. I'm not a very good snake person. I hate to say it, but personal preferences. All right, next we'll go to Emma from Meridian Township, who's going to talk about invasive species monitoring. And I know I've pulled a lot of garlic mustard in Meridian Township.
Thank you so much. The app I'm going to be talking about is great because you can make your own data form. And where I have that you can put in, did you pick garlic mustard? I said, thank you for pulling a terrible invader here. All right. Okay. So in Meridian Township, we have, the invasive species strike team with the Meridian Conservation Corps. But, invasive species management and monitoring can happen anywhere and really should happen anywhere. So before we go on any further, I'm going to do a very, very quick lesson of what an invasive species is and why we even need to think about them. So these are a lot of various pictures of invasive species. They do not have to just be plants. I deal with plants in my job every day, but they can be insects, animals, mammals, fungi. So they're everywhere. And we are not the only place in the world that deals with them. Everybody has an invasive species that they deal with. I mean, we have species that are native here that are invasive, in another country. So invasives are non-native species to our area. They don't occur naturally. But the difference is, so a hosta is not native, but we don't see it taking over natural areas. The difference is that invasive species come in and they cause harm economically and environmentally. They can cause harm to human health. Most people are familiar with Asian carp, and you can see this picture down in the corner. You can see how they can really do a lot of harm to our fishing industry in Michigan, which is huge. They simply take over, they create monocultures. So a really good way to think about it is a cornfield. In a cornfield, corn is the only thing that grows. And as you can see in these pictures, these invaders are certainly taking over. So when we think about walking into a really nice woodland habitat this time of year, or, in a few weeks, we'll be seeing more of our spring ephemerals blooming, we can expect to see something like this. If it's a healthy system, let's say in a beech maple forest, we're going to see lots of different species. There's trillium here, bloodroot, Dutchman's breeches, squirrel corn, pawpaw flowers, and these are all native species. So this is just a PowerPoint representation of the diversity we can see. With invasive species, the reason why they're such a threat, if we walk into a system that's not very healthy this time of year, that maybe is really disturbed, it's just not been taken care of, and there's a lot of disturbance going on, we might see this. So this is garlic mustard. And when we look at this garlic mustard, we think, how can those little spring ephemerals that are only about this tall, how can they compete for sunlight with these invaders? There's invasive species that occur all different times of the year. There's different treatment methods. There's a lot that goes into identification and management. And that's where all of you come in. And, coordinators like myself, land managers, they can provide you so many resources to deal with these invasive species. But as you can see here, it's open to all ages. You can manage on your own property. But really our local natural areas, they need a lot of help. So the biggest thing that, I always let my volunteers and residents in the community know is even if you have good intention and you want to go out and pull garlic mustard, you really need to be checking with those agencies before you're going out and removing anything. In Meridian Township, we have an ordinance where you are prohibited from removing any natural item from our parks and preserves. So even something, like a flower, you can't pick that and take that. So the reason with invasive species why we have to be careful is, not only do we want to know what you're removing and we want to keep track of your hard work. That's a big thing with me is I want to document all those hours that you spend giving your time. So it's really good to be in communication with whatever land manager is in charge of the area you're deciding to do management in. And if you're a homeowner and you're doing it on your own land, well, then you only need permission from yourself. But it's just very important too, because you might think, I've had experienced volunteers that they think they're taking something that isn't invasive, and then we find out that it's actually a native that looks close to it. So it's really important to utilize all your resources and educate yourself and just take time. It's not a race when we're out there in the woods. It's a chance for us to slow down, take some time, use applications like iNaturalist, and I have Seek listed here. Seek is another application by iNaturalist, and it's very similar. I introduce people to Seek because you just open it up and you point and it starts identifying. I really like iNaturalist. I use both of them. I think iNaturalist, both of them store the information and you can see the recording of the species. So it just kind of depends on what you're more comfortable with. But it's very important to just, slow down, make sure you're identifying everything correctly before you go ahead. The land manager might also have areas in mind that they would like to prioritize. A lot of volunteers who come to me want to attack these crazy dense areas that are just acres of invasive species, which, trust me, I want to get to those places too, but those areas are already degraded, and we might have a really nice woodland forest with a lot of spring ephemerals that's starting to get garlic mustard invading, and that's an area that we want to take care of first. So it's really important when you're doing this type of monitoring to just be in communication with that person. It depends where you go. Some land managers are able, they have a more budget, they're able to be more involved, they have more hours to spend toward it. Some aren't able to. So it just depends, but you really need to make that contact first. The other app that I really love to use is Mizzen. Mizzen is the Midwest Invasive Species Information Network. And I am actually going to, so this is the Mizzen website. It's an incredible resource for someone like me who's a program coordinator. They have training modules on invasive species that are really common here that we deal with a lot. And so you can, I always have my volunteers go through this process and recommend certain species that they might encounter and go through these training modules. So your resources are right, at your fingertips. You can do this on your computer. You can also use your phone. And then Mizzen also has their app, which is really cool because Mizzen is kind of like iNaturalist for invasive species. So when you open up the app, you can identify invasive species. You might, you know, say how many, or, you know, what's the area, how dense is it? And it is, of course, you know, GPS oriented around your location. And so you can say, oh, I found a patch of Phragmites here. And as soon as you send in that information, it goes to a statewide database. And then different coordinators around the state, different SISMAs. Our SISMAs are Cooperative Invasive Species Management Areas. They can, you know, be made aware of certain areas that they need to monitor or treat. And so MISN is great because it's educating, it's outreach, but it's also informing people who are doing the management of where we need to prioritize these areas. So that's a great way to be a citizen scientist. The great thing about MISN too is that there are identification descriptions and pictures right on your phone. So while you're out there, if you're not sure what it is, you can use your MISN app, and you can also use Seek to guide you. Now remember that these are guides, and we want to do a very thorough check of, you know, I'm not just going to take Seek 100% right at first. I'm going to make sure that I look up everything and that I'm looking at the correct species. So in a nutshell, that's what my program is looking to. That's the mission, is, you know, educating on invasive species, giving you the tools to educate yourself and to do the management. And then in my program specifically, I use 123, Survey 123, and this is a really great program, whether you're a private landowner and you just want to collect data, or if you're a program coordinator. This is a very cool program where you can essentially create your own data forms. So, you know, in the past, it's all been paper, and then you got to bring paper out with you and a pencil or a pen. And here it's just right in your pocket in your phone. So you can access this with your phone. So I give this information to my volunteers. They have access to this form. And then anytime they go out, which, you know, I make my volunteers go through a lot of training before they can go out on their own and remove invasives from our preserves. But even every time I go out with a work group, I'm going to be filling out this form here, date of stewardship, time. And again, just like Kristy and Dan said, all this data collected is not only just a good way to keep track of the management we're doing, but it's a really great way to know, okay, the garlic mustard came out earlier this year, or we're noticing that this is really effective to treat this at this time of the year. So any edge that we can have over invasive species management is going to be really great. And so being able to collect this data in this form is a really wonderful thing. So these are ways that I'm connecting my volunteers with invasive species, and just trying to get the word out, because that's really how we're gonna get through the issue of invasive species and start making our natural areas healthier.
Great. Thank you, Emma, for sharing that. I know invasives are a terrible problem. I spent 15 years out in Pennsylvania, and we were overtaken by multiflora rose and a mile a minute plant. And I'm hoping mile a minute doesn't come up to Michigan, because it's even worse than multiflora rose. Fingers crossed.
Well, I have ruined gear on multiflora rose many times, so it is one of my enemies for sure.
All right, and now we'll pick up with Steve, who's going to talk to us about monitoring weather and what it's used for, and how it's helpful.
Oh, absolutely. And I'm going to echo your comments. My wife and I have spent an awful lot of time in our little woodlot pulling garlic mustard and multiflora rose, and going crazy every time we find some new exotic invasive that has invaded, and it's a challenge for us every year. So that's really important. So what I'd like to share now is really kind of the next steps. Let's say, for example, you've always wanted to be engaged with monitoring weather. You've find some interest in that, and you every day anxiously await the weather report at the end of the day on what the precipitation has been, and you want to become part of that. So one way to do that is to become a member of CocoRa's. And CocoRa's, as I had described, is an operation program that was created a number of years ago at Colorado State University. And CocoRa's is specifically for monitoring precipitation, whether it is solid or wet precipitation, liquid precipitation. And the cool thing about CocoRa's is it has over 7,000 members throughout the United States, Canada, and Central America. So let's say, for example, you've decided to take the plunge and become part of CocoRa's. What would be your first steps? So if you happen to live in the state of Michigan, I would encourage you to reach out to the volunteer coordinators for the state of Michigan. So let's do exactly that. But who is the state coordinator but my colleague, Dr. Jeff Andreessen, with the geography department? Jeff happens to be the director of the EnviroWeather program, and what a better person to have for the guidance of the other state level directors for the regions of the state of Michigan. So one would choose your county, reach out to that individual within your county or to Dr. Andreessen, and as a result, you would be provided a training video along with your precipitation gauge. So let's take a look at what the training would be like and why it would matter. So CocoRa's is a simple organization for taking real-time measurements manually of precipitation. CocoRa's will help guide you through the process of installing the precipitation gauge that they supply, along with an understanding of the proper way in order to take those readings. Well, what do you do with the readings once you've taken your precipitation reading for that day? You report it either directly onto the website through your login that they provide or through the app that CocoRa's has developed. I've personally found that for manual reading, it's a great benefit to have that app right on your phone. You're standing next to your precipitation gauge, you enter the data and then empty the precipitation gauge. You're going to provide the timestamp and date along with the data. This data is then fed into the database. The database for your station will consist of readings throughout the time period archived for your particular station. And if you'd like to look at other data from other stations, you can change the station that you're interested in looking at and do a comparative analysis. CocoRa's offers a plethora of different trainings so that you can further your understanding and education of how it is used and also how to improve in your measurements. But what if by chance you would like to go to the next step? Instead of taking manual readings with manual precipitation instruments, you'd like to have also temperature, perhaps relative humidity, wind speed, wind direction, along with even solar radiation. You want to take all of this information and use it to make some decision, perhaps for your own home garden. Well, the next step is to pursue investment in one of the personal weather stations that's offered. There are many manufacturers. Some have advantages over others, but they all have the basic same instruments. They're going to provide you with near real-time data or information for air temperature and relative humidity, the precipitation, wind speed and wind direction, along with possibly barometric pressure, solar radiation, and even a lightning detection if lightning is in the vicinity. These pieces of technology require a little bit more maintenance, a little bit more understanding of electronics, but by and large, there are a lot of resources for support and care of the equipment. So how might you put this to use? One of the best ways for the average person is to use it for your home garden. Installing the weather stations does require to follow a specific set of guidelines for standard installation. The idea behind automated weather stations, even if it is a personal station, is to have the data from your station capable of being compared against data at other weather stations. That means that the location, the surroundings of that weather station, along with the actual installation of that station, mimic or carbon copy other stations. There's a set of standards for these and guidelines along with training that goes along with each of the instrumentation pieces of technology. For example, the precipitation gauge, the precip bucket we call it, should always be installed 1 meter above ground. The air temp relative humidity sensor, approximately 1.5 meters, and so on. That way, we can compare data, like data, to another station of like data. The only variable is either the geographic location or the information that's being collected. So it's always important. So what would that look like? So one of the particular weather stations that I happen to own is a Davis weather station, and I have a short video that I can play.
Our planet, our weather, every day, everywhere. The Davis Vantage Pro 2 helps professional users measure, monitor, and manage weather data. Davis weather stations are engineered and tested to withstand scorching sun, corrosion, 200-mile-per-hour winds, temperature extremes, or anything else the weather can throw at it. The Vantage Pro 2 is expandable, transmits wirelessly up to 1,000 feet, and updates every 2.5 seconds. The Vantage View incorporates many of these same features and is a sleek, compact, integrated weather station that's affordable and easy to set up, so you can have the best. In your backyard, at a school, or anywhere weather matters. Davis stations can weather any storm. Others simply can't. Davis, rugged, accurate, reliable.
Okay, so interesting piece of technology, but what happens with the data? Well, once you have the data from your weather station downloaded, it can then be contributed to the National Weather Mesonet system. And the Mesonet system is operated by Utah State University, and it's a clearinghouse of information and data for personal weather stations. So here's an example of the data that comes in on a daily basis, actually a 15-minute update from my own personal station. I provide temperature, dew point, relative humidity, wind speed, pressure, and solar radiation data. This information is then used by others that are interested in doing a climate study along with an analysis of changing climate and the changing weather patterns across the country. What'd be really wonderful is if we could take all of this information and feed it into larger weather station networks that are used for commercial agriculture. And that's something we'll talk about a little later. Thank you.
Thank you, Steve. And now we'll go to Joshua Hamilton, who's going to tell us how to get involved with the NASA BioDisc program.
Thank you very much. So again, kind of following up on what I was talking about before, Zooniverse offers tons of opportunities, including a lot of opportunities when it comes to space. So my project, NASA's Disk Detective Program, I'm going to share my screen so you can see. If you're watching now, I'd even encourage you, if you're able, you can download Zooniverse onto your phone and look for Disk Detective, or you can, of course, Google Disk Detective Zooniverse. And you'll come to the home screen of Disk Detective. Looks like this. You can actually see we've got about 6,000 people working on the current version of the project. It's 99% complete, and this is version 2. So we've already completed a first set of data. This is another set of data. This set is 25,000 WISE images, and you'll notice there are about 382 classifications, 382,000. The reason for that is simply we want verification, and all the folks here have talked about that, right? When it comes to citizen science, you want to make sure that you have accurate information. But this isn't just because you're maybe not a trained scientist. Even trained scientists have to go through a process where their peers verify their data. And that's a good thing, right? If you've ever seen studies published by the company who's going to sell the product and you're maybe a little skeptical, science has actually got you covered because they work to verify things. This is peer review. So I'm actually writing a paper myself that I'm going to publish soon, and I'm in the peer review process. So I had to submit the paper to a team of astronomy professors who reviewed it and sent me, 3 pages of critiques that then I need to edit, or maybe they're pushing back on things. This is a process that all scientific research goes through. So I think one of the cool things about citizen science, whatever way you get involved, in a world where maybe science has come under some fire, facts have come under some fire, citizen science allows you to see the inside sort of view of science. You see the amount of scrutiny and the amount of work that goes into making sure that scientific data is accurate, unbiased, and helpful and useful and relevant. So again, that's kind of our project. So if you click Get Started, it'll actually bring up a little training if this is your first time doing it, and kind of walk you through. It's actually quite simple what you folks would be doing at home. And again, I'm hoping you're even working on downloading it because it really is a fantastic program. You'll see on the top here, this is the name of the survey. What we're using is a variety of surveys. The WISE data is the most important, but these other surveys are also relevant. And basically, you've got a set of things that you need to look for. Let me just move this little video so I can see that well. So the first thing you're going to look for when you hit play, does the object move off the crosshair in 1 or 2 directions, or in 2 or more images, sorry. So the crosshairs, again, being right here in the middle. Is the object not round, right? If it's a star, the object size is going to change, but we expect it to be round. If it's not round, that's an indication to us that it's likely a galaxy, a quasar. If you don't know what a quasar is, quasars are black hole emissions. They're some of the most distant objects in the universe. They're at the very edge, 13 billion light years away. So the light from a quasar that you would see, I've looked at one in my telescope before, that is light from near the beginning of time. It's taken that long to get to you. Quasars are amazing. However, not relevant for our research. So that's a way to filter those out. If the object moves off the crosshairs, I should have said this as well. Again, it might likely be something other than a star that we're looking for. It might be a really young star that is not going to be useful in our research, and that's why it's moving. Again, some of these images might be shot, maybe the Pan-STARRS images were shot in 2012, the WISE image is shot, 6 months later. If you look in the night sky, stars do move, but if a star moves significantly in 6 months, it's a different type of star and not relevant for our research. As again, you don't look up in the sky and see stars move that quickly. The next one, object is extended beyond the outer circle in the WISE images. So again, when you see WISE on the top, you're going to want to look, is it go outside of this red circle? The reason for that is simple. The image, the little star here in the middle, it's going to emit heat, and that heat is going to be reflected off of this disk. So imagine almost like you're outside and there's a light, and then you have like a foggy window or curtain, and when you shine the light, it actually creates like a halo. And what we're looking at is each of these images looks at a different temperature range. And by that, we can tell actually what the light is shining through. Is it shining through gas? Is it shining through dust? How much dust? Is it sand particles? Is it big particles? Is it chunks of ice? We can learn a lot about that. But if the whole image is a giant foggy cloud, that indicates to us that the star is actually in the middle of a dust cloud. Nothing wrong with the star, but it's not useful for our research because we need to be able to separate that star into its own little category. So if it's part of this big cloud of dust, there's no way for us to know where the disk begins. And you see this in my background is a really nice, clean example of a disk. It never looks like this, right? There's disks and dust and everything. And we're trying to find those rare, clean objects so we can learn about the star. The next thing, 2 or more images in the inner circle. Same problem as before. Often stars come in, stars are not alone in the sky. So you might have 2 or 3 stars in the middle of that red circle. Likely those stars are not next to each other in the plane, like they're not sitting next to each other. One might be 10 billion light years away and one's 100 billion light years away. But of course they both show up as if they're right there. Problem with that being, again, there's no way for us to study the disk around the star because we don't know if the light and heat is coming from the star that the disk is around or the other star in the background or foreground. So we can't use those stars for our research. Again, 2 or more objects in the middle, in between, I'm sorry, so I jumped those. This is 2 or more images in the inside circle, that tiny little red circle. I'll come back to that. What I just described is if you see something between the inner and outer circle, and I'll show you what this looks like, you'll see it very clearly. If there are 2 or more little dots inside the red circle, you indicate that. And our citizen science team, we actually go, we look at the research and we try to see, are those 2 stars that are really close together, are they like brother and sister, basically stars, or are they actually in different planes? If they're in different planes, far away, then we can't use the star. But something most folks don't know is most stellar systems in the universe, stars come in at least pairs. Our star is very rare in that it has 1 star, and actually many scientists believe that our star had a sibling that got thrown out of the system. Often that'll happen if there's a 3rd star introduced, and it will create a little bit of kind of whipping motion that will whip both stars out of the way. But our sun probably had a pair simply because statistically a single star is extremely rare. And so if we see 2 stars that have a disk, we just want to know that that's different than 1 star with a disk, but we want to research both. Lastly, none of the above. Now this is good. If it's none of the above, that to our team is a key indication that, in fact, this is something we really want to look into because it's completely clean. So if you come over in the left-hand corner, you'll see there's a play button. When you're going, you can actually adjust the speed. This is how I do 75,000 objects, is I get really good at looking quickly and I make them go really quickly. But again, you can change the speed to whatever you want. I'll show you how it looks when you play it. And again, look for those things that are in the corner and see if you notice any of them. Okay, so I'll run through those one at a time. Okay, on this image, there's nothing that meets any of those qualifications. Single star in the middle looks good. It's still looking good, but you got to watch out for, you'll see there's like little tiny white specks. This is why it says, is there multiple objects between the outer and inner circle, 2 or more images. If it shows them in the same place twice, it's a star. But there's also a lot of noise. So in these first couple of images, you'll see little blips of light, but they don't show up consistently. So we keep moving. We're in pan-stars, which is another robotic survey. 2MASS is another robotic survey. I don't see anything at this point, right? It's a normal star system. But if I keep going, I gotta move the closed caption out of the way. Okay, so now we're getting into the WISE images. Again, this is heat-based. So you see the disk starting to form. And again, this is temperature. So we're going into different temperature ranges. It's looking fine to me. And then all of a sudden something happens, right? And this is just at a different temperature. You see all of a sudden the object sort of disappears. There's this large object in the far right. And that's a sign that there's a large dust cloud that's resonating at a certain temperature. And the final image again. So this, you would simply click that this object is extended beyond the outer circle. And you can see that it moves off the crosshairs because it does. And you hit done. If you hit done and talk, this is where we have our discussions. So sometimes we'll have things like, I'm not sure about this, or what do you think about this? Like they mentioned with iNaturalist in particular, you can say, I don't know how to identify this. Better to ask than to incorrectly identify. Just show you maybe 1 or 2 more examples. So I can already see some multiple objects, but I want to confirm that they're actually multiple. But if you look at kind of 2 o'clock, 3 o'clock range, there are a couple little dots. And so I'm actually going to manually click forward. See how that dot at about 2 o'clock stays between the 2 images. The other one actually disappears, so it's likely not a star, but it only gets more sharp and clear, and maybe even another star. And I'll just see if there's anything else interesting in this. And it dissipates again into a cloud of dust. So you've got 2 or more objects between the inner and outer circle. extended, next, one more time. I'll play through quickly. So that's a none of the above. Now, if you're an average person using this, you'd simply click none of the above, move on. If citizen scientists like us are using this, since we're going to eventually do the research anyways on the star, I'll actually start doing the research on the star now and come up with a prognosis as to what it is, what kind of star. And again, on the back end, so you know, as you do this classification, sometimes it can seem a little mindless what's happening with this data. Once you say none of the above, or that there are two little objects in the center, our citizen science team every month gets a report that's basically, here are the objects of interest for you to review. It comes in an Excel sheet that we share. Typically in a month, we'll have as many as 200 objects to look through. And we run them through these massive databases. And we've been trained to basically look at tables, giant tables of numbers that made no sense to me when I first started training. And again, I have no scientific training. I haven't studied science in college. It's amazing that they were able to train us to look at these numbers. And I can see, okay, if the B value, which is a type of light, minus the V value equals this, then it's an M star. And stars are classified based on age, size, and heat and temperature. So we really want to know what kind of star is this. For instance, if you have an M giant, so if you've ever seen Betelgeuse, which is actually in Orion, which is the guy that's kind of going like this up in the sky, he's got his belt. Up in the corner, there's that big red star, hard to miss, that's Betelgeuse, M giant. Problem with an M giant is they actually belch out dust. And so they're not an accurate use for our research because we don't know what is the dust cloud and what is the sort of coming off of the star, being belched out of the star. Versus an M dwarf, which is really relevant because those are small stars, they're close, and we can actually get a lot of measurements about them because of how close they are. So just the kind of background research that goes on. And then if, out of that list, maybe we'll come up with another 20 or 30 objects out of those 200 that we send to our scientists, Dr. Kuchner, Dr. Silverberg, and we all meet together once a week and we talk about these objects and say, should we submit them for research? So for instance, a number of stars that we've worked through, we've actually submitted to the Hubble Space Telescope for observation. Now that's a hard proposal because every hour on some of a telescope like Hubble is worth about $100,000 of taxpayer money. So it can't be like, this is a cool object, let's take a picture of it. We have to say, this is $100,000 worth of research here. We need these images. And that doesn't count the time that it takes for the telescope to slew, which is to actually point and aim. So we have to have, to use one set of pictures on Hubble, we have to type, 20-page papers that basically are groundbreaking research that say we have to have these follow-up images in order to know. But when we found our Peter Pan disk, for instance, which we've now found, I think 4 or 5 that are in that class, we did actually seek time on the Hubble Space Telescope simply because this is worth it. This is groundbreaking. This is something that's never been observed before, and we need that kind of caliber of scope. But there's lots of ground-based telescopes at all the universities around the world. In Hawaii, some of the big mountain villages in Chile have great telescopes. So all year we're typing up proposals to get time on these scopes to look at our objects and follow up. Another cool thing, and I'll show you, my wife and I actually were able to visit the Goddard Space Center, where our project's actually based out of. Dr. Silverberg is on the right, one person in from the left. Behind us is actually the James Webb Space Telescope being built. It's like the single most expensive piece of equipment that's ever been built in human history. Not just because it's a few $1 billion over budget and a few years behind plans, but just because it's a really humongous scope. We were actually even able to participate in some citizen science talks while we were there, which was pretty neat, talking to NASA scientists about the importance of citizen science. And just a couple other things. I know that in my bio it mentions naming a couple of stars. So I'll show you, this is a profile of one of the stars that I was able to discover. The cool thing about astronomy is, just like in into the natural things that were discussed, there's more stuff out there than there are people to look at it. So you always have the opportunity to be inventive. So I work with an organization called AABSO, the American Association of Variable Star Observers. And you're basically looking, again, I look through robotic telescope data, and I look for they basically take images of how much light a star releases over time. And then they're looking for, does that light fluctuate up and down, up and down, up and down in a certain pattern? And when you see a pattern, then you can decide what kind of a system it is. So if you look at this graph, this is a graph of HGRA1. And so as I was looking at the star, this is the light measured in brightness. You notice how the star dips at a very regular motion. Now this is called a phase plot. So what I basically did is I took all the data over time and I sort of overlapped and I said, what if we assumed that the star has a period or a cycle of 3.50735 days? And then I picked a starting day and I just layered all the data like that, as if every piece of data starts on that date. And you all of a sudden it's like, you know, you see this moment of like, wow, like this is a star. It's called an eclipsing binary system. And what that means is there's two stars that are spinning around each other, a smaller star and a bigger star. And you'll notice the bigger star here in the very middle just slightly darkens things a little bit more than when the little star crosses in front of the big star. So you have in the middle, the big dip, and then the little dip, and then the big dip, and the star has been doing this for billions of years. But no one had ever discovered that this particular star was a variable star. It just had been taken in a robotic survey. So just all that to say, citizen science is really an incredible way for you to get involved in any kind of research. I mean, 30, 40 years ago, I don't think most folks would have imagined they could help NASA because they, couldn't ride along on the rockets out of outer space, et cetera. But now you really can make valuable contributions to stellar research.
Well, thank you, Josh, for all those stars out there to be discovered. I think when we initially talked, you said people have the opportunity to see things that no one on Earth has ever seen before, which I really love that.
Yeah, some of those stars that we just looked at today, I have no way to know, but many of them, we're seeing them for the first time. So one of those 3 stars that we classified, we may have been the first humans to ever lay eyes on that star, which is pretty amazing.
Well, we are out of time. I think we have 3 minutes left. I see any questions from the audience, but if anybody has a question, we have a couple minutes left. And for my panel members, do you have questions of each other that you wanted more information about? Now's your shot. But I thank you all for being part of the panel. And I hope the audience saw that there's many ways to get involved as a curious citizen out there, just to get outside, observe nature. Some things require being on the computer, some require equipment to monitor the weather, but everything is doable as a community-led project. Any questions or comments?
I have a comment. I just want to say that this was very valuable to myself. I downloaded the Zooniverse while you were talking. The app is super easy to use and it has so many, and of course, when we first talked about it, I didn't download it at that time. And I looked up, the weather collection. I mean, that is so cool. And just as someone who's a communicator with 200 people now in the community who are very interested in this stuff, I'm super excited to send all this information to my volunteers. And so thanks everyone, and all the birding. There's just a lot of amazing things. So thank you so much, everyone.
And I guess I have a question for Christy. With all the different bird apps out there, do you put information into all the apps? Do you center on one? As a scientist, I guess, as a curious public person, where should we put our stuff?
Sure. That's a really good question. When you're getting started, I would recommend using the simplest program that makes sense to you. So when I first started birding, the program I used on my phone the most was probably Merlin Bird ID. But now that I'm more proficient in identifying birds and keeping track of the quantity and species, I recommend eBird. eBird is really valuable to scientists. That data is valuable whether it's a parking lot at Meyer and you're noting that you're seeing ring-billed gulls and house sparrows, or if you are traveling and you can keep your own list of birds, so it'll keep track for you of the birds you've seen in your backyard as well as the birds you've seen on your travels. But yeah, I would really invest some time learning how to use eBird. It's really valuable for scientists and it can be plugged into a lot of different applications. So
Awesome.
great question.
Awesome. Anything else from the group? We are right at noon, our end time, but thank you again for taking part in this. My goal for the Science Festival was to get people outside and observing nature, or if they can't get outside, to use the computer to get involved in science, to remain curious and be involved. So thank you, everyone.
Thank you. Have a great day.
Thank you all. Bye-bye now.
Bye-bye.
Thank you.
Thanks.